This problem is a problem related with the conservation of the energy. As you can see, you have a spring mast, and then you have a plane, a raised plane, or kind of inclined plane. And the question asks, if you know the property of the spring, in this case, a spring constant, and if you place a mass and then compress the spring, and once you release it, how high it goes up the slope? That's the question is. So just have to use the principle of conservation of energy in order to calculate this, in order to solve this problem. So in this case, once you compress the spring, once the spring is compressed, all this energy is stored in the form of elastic potential energy. And once you release it, this elastic potential energy changes into the kinetic energy and then again stores in the form of gravitational potential energy. So here the conversion is happening from elastic potential energy to kinetic energy and then again to the potential energy. So let's find out what is the elastic potential energy stored in the spring. Okay, so as I mentioned here, so you just need to convert. So we have elastic potential energy, elastic potential energy. The PE means elastic potential energy, and this one changes into the gravitational potential energy. I'm just calling gravitational, and PE means the gravitational potential energy. Okay, you need to know what is the elastic potential energy. You see here, elastic potential energy. What is the elastic potential energy? So this is a property of a spring, and the elastic potential energy is half k x squared, and the gravitational potential energy is simply equal to mgh. We need to find out the height, how high this block goes up. So once you compress this one, the elastic, all the energy is stored in the form of elastic. When you let it go, then the elastic potential energy changes into the kinetic energy, which makes it to go to the certain height. We need to find out the height h. So this one is kx squared over 2mg. We know all the information here. What is the k value? The k is given 140, and it is stressed, compressed by 11 centimeters. So you need to change this 11 centimeter to meter. So the 11 centimeter to meter is, I'm just simply doing 11 times 10 to the negative 2 square. This is in meter. 2. What is the mass? The mass is 50 gram block. You again have to change the 50 gram to the kilogram. So in order to change the 50 gram, the 50 times 10 to the negative 3 is the kilogram. And G value, as you know, is 9.8. 9.8. So once you do all the math, the answer you will get is 1.7 meter. 1.7 meter. Let me tell you one thing before I wrap up this problem here. And if you assume there is no frictional force, what will happen? This block will go to a certain height and will come back and then compress this spring again, will go back again, and then there will be an oscillatory motion, and it will continue forever if there is no friction. But that does not happen. There is always some friction in the system. Okay, so it will stop at certain point. But if there is no friction, this block will go up, come back again, compress the spring, go back again, and there will be an oscillatory motion